University of Cambridge recognises climate change as the greatest human challenge of our age. The impacts of climate change are now being felt in every region across the planet, and as the United Nations has stated, a 1.5 degree rise in the average global temperature would be devastating for people and for nature. Solutions are being developed at Cambridge which can be implemented, grown to scale, and used to accelerate the rapid transition to a net zero and then zero emissions economy. In this summary video, you'll hear from a collection of academics working in areas where Cambridge is a world leader. The university has a rich history of discoveries which have changed the world. That gives us the hope and the confidence to believe that we can create a sustainable future. A future in which we, our children and our grandchildren can thrive.
I currently work in the area of solar cell technology. It's really important. We are going to transition away from fossil fuels as our primary source of energy, and most of that is going to come from solar cells for the very simple reason that we have unlimited sunlight that lands on the Earth at the moment. We only need to harness a tiny fraction of a percent of what lands on the Earth to satisfy all future global energy needs. The challenge, if that's going to happen, is to make it cheap enough, and to make it cheap enough, we need to make it more efficient, and we need to go beyond what we do with silicon. And that's the space I'm working in.
In our lab, we are developing the current generation of batteries, but also developing the future generation to speed up the energy transition, in particular in two sectors, the transport and energy generation. And in our lab, what we specialize is in developing also experimental techniques that can look inside of the batteries while they're running. So we can shorten the development of these batteries, and we can work out whether they're going to fail and how they're going to fail, and hopefully solve those issues before they happen in a much shorter time scale that the battery companies can do. We are trying to develop the batteries that will last much longer, that will cost us a lot less, that will have a lot less environmental impact, so we can hopefully help with the energy transition and accelerate that.
So we're looking at a number of problems in energy transition related to, first of all, carbon storage, which is a key part of the whole energy transition. So capturing carbon dioxide from the atmosphere or from the emissions from a lot of industrial processes such as cement and iron and steel manufacture, and then taking that carbon dioxide and storing it in subsurface geological structures such as deep saline aquifers or depleted oil and gas fields, has the potential to accommodate up to about a quarter of the present emissions from fossil fuels. And the IPCC envisage that in order to meet the 1.5 degree target, we need to be storing that volume of CO2 every year from 2050 to 2100. So understanding how CO2 travels through the subsurface and both the security and effectiveness of storing CO2 in these reservoirs is the centre point of a large part of our research.
So we use MRI and magnetic resonance methods to look at systems of interest in chemical engineering, like reactors or porous media. And what MRI can do is it can give you information about what's going on inside a system without opening it up. So you can get images of where chemicals are being produced and where chemicals are being used up, and you can also get information about how fast they're moving and diffusing, which are all key aspects in understanding how reactors work. And if we can develop this understanding, then that means that we can also develop new ways to optimize these systems and to develop new reaction pathways, new reaction systems, so that we can then work out how we move from the systems that we're using now into the energy transition, where we're looking at producing similar types of products but using new processes, using recycled materials, and form a whole sustainable circular economy.
The aim of the Whittle Laboratory is to decarbonise flight. And the problem is that the climate impact of aviation is set to double between now and 2050. And even though all of the world's aerospace researchers are actually working to reduce the emissions per passenger kilometre of flight per year, it's still rising, because in 2018, only 11% of the world had flown. And as you have the rising middle class in Asia, Africa and South America starting to fly, this is going to drive up emissions. So there's no alternative other than for us to, as rapidly as possible, decarbonise aerospace. And that is the objective of the lab.
Getting to zero carbon by 2050 is a real challenge. We can get there. We're all going to have to play a big role. The challenge for Cambridge is that it is something we're all engaged with. It's not just for the engineers to deal with, it's for all of us. There are opportunities everywhere, and we need to lead. We need to demonstrate where we can find solutions that take us forward. It's got to be a big collective effort.